Hey everyone, welcome back to Thwack Camp and to our session, which is, what again? I feel like with you two on camera, we could talk about pretty much anything.
Yeah.
Well, we're showing all of you system and application types how to monitor the infrastructure like a true network engineer.
Okay, don't lump me in with Linux Boy over here. I'm perfectly happy at layers 1 through 4 of the OSI model.
Wait a second. You have to admit we needed this session because last year on Thwack Camp, we had a whole thing telling network engineers how to monitor like SysAdmin, so fair is fair. Also, I was installing Token Ring on DOS machines using ODI drivers so they could log on to a Novell server which was running on a VAX machine, so stay off of my lawn!
Before Leon strains his orthopedic pocket protector, I want to start by looking at how network engineers think about network problems and how that influences the way they solve them.
Yeah, but we also want to look at how that's different from a typical sysadmin troubleshooting process. So let's get started. I'm Technical Content Manager Kevin Sparenberg.
I'm Head Geek Destiny Bertucci.
And I'm apparently the designated old fart, but I'm also Head Geek Leon Adato.
Why is network monitoring a challenge for sysadmins?
Okay, so I think speaking from both sides of the fence, it's not a skill that you can master very quickly. I mean, like iOS isn't something that you just jump into and just like click around and figure out, right?
That's the way you break it, yes.
Well, but the concept's the same, an iOS versus an OS, right? Or is that just something that's just like far-fetched to think about?
Even being a command line aficionado, you know, I mean, again, Linux and all that stuff, still, the first time I got into a router, it was a whole different world. It was not responding the way I was expecting it to. It wasn't giving me the information back the way I wanted. I think that's part of it. I don't know about your...
Yeah, a lot of the times the returns come back and you're like, okay, well, I'm going to just show me information about this. And you get this laundry list and you're like, what's the important part? Mm-hmm. Because in a CLI that we have on Windows Core or on Linux, it's like when I ask for something, I get exactly that.
Right.
So iOS, for me at least, and now NXOS and the other new ones are just, it's like 25 degrees off of where my head is, and adjusting to that new vector is actually tough.
Yeah, and I think also the layers, you know, you can't, on an OS, I get in, and as long as I have administrative rights, I can see anything I want to with a series of commands, even if I'm doing PowerShell. Yeah. I don't have to get into config mode, and then from config mode to interface mode, and then from interface mode into security interface mode.
And to know what levels give you what information, because a lot of the times that I've always seen is the sysadmins that just find show commands that are out there, and they assume that they can do it at every level, but there's only certain information at an enable versus global and config.
Yeah, well, there's a lot of problems with that in general. It's like now, because when I was learning, there was 15 layers of enable, so you could assign all these different things. So you're talking about the granular rights. You can really get super granular. But if I want to take even a smaller step back, when I talk about layer 2 versus layer 3, this is why I learned on router on a stick, was so I could actually conceptually separate those, and then after that, collapse them back onto the same piece of hardware.
Right. But again, for the sysadmins in the audience, I think we're going a little bit deep.
Yeah.
You know, I think again, at the high level, the reason why sysadmins find it to be a challenge or a little bit daunting is because all the landmarks they're used to seeing aren't necessarily there. That doesn't mean that it's impossible to do. Obviously, it's just a different mindset that you have to get into.
Yeah, I agree. But I mean, that is kind of how the sysadmin sees the world. I mean, really, if I can go from this machine and talk to that machine, whether it's physical or virtual, I can talk from here to there, that's good enough, right?
Right, we don't care if we made a left turn at Albuquerque and then like it's just, I get there. I don't care how I got there.
Well, and in virtualization, you can also just back up, right? And you can do snapshots, and you have like all these really great ways to grab everything that comes across there versus I have to download a config and be able to put that back into the bare bones.
Control Z is a wonderful, wonderful thing.
It is happy.
It's one click away.
I also think for better or for worse, in a sysadmin's environment, it is a GUI world.
Yeah, I mean, predominantly, yeah. Even on Linux, a lot of at least when people are getting started, you're using a GUI of some kind on it just to kind of learn your way around. But you don't always have that option with network gear. In fact, very often you don't have that option at all.
Right. I mean, menu driven gives you a little bit of a taste of that, but it's still not the same thing as what the command line interface is. And a lot of the times we like streamlined, right? Like I liked it to be stripped back, especially in a security and network world.
Yeah.
I just want to see bare bones, what do I need to get to? And for me, CLI, that's where my happy place is. When you start putting a lot of GUIs in it and things of that nature, I also start thinking security holes.
Yeah.
Right, but that touches on one more thing that I think is a challenge for sysadmins, is that network gear can have multiple personalities.
Oh yeah. I mean, if you want to talk, let's just talk just the firewall. Let's just say firewall. A firewall, is it a router? Can be. Sometimes you turn that on. I mean, is it a security device? Well, most definitely it's a security device. Is it a switch? Well, it kind of depends what's installed in it. You know, is it a VPN endpoint? Again, depends. I mean, just that one device has like 16 different personalities depending on the licensing you get for
and
it.
like network, we think and see the IT world a little bit different too, because we're the infrastructure of which that you're sitting on. So a lot of the things of which that I look at is like logical versus physical, means completely different things. I know you guys don't really care about where the copper goes, but like for me, there's a logical situation that server guys only see or are aware of when actually I know the physical layout on the backside, and I'm like, no, there's actually 6 devices back here that you just assume that it's one.
And it matters.
And it does matter.
Yes.
So before we freak out all the sysadmins who are watching like, okay, that's it, I give up again. I think one of the points I want to make sure we drive home in this session is that if you're a sysadmin and you are responsible, you're an accidental network admin, that it's the tools that can help bridge that gap. Right?
Yeah,
that if you
absolutely.
have the visibility into things, you're not typing 3,700, layered commands or whatever it is, you're getting in there. And that's part of what we want to show, right? Is that it is doable. No, you're not going to automatically become a CCIE if you have the right set of tools, but you will be able to get the job done.
Yeah.
Correct.
Good.
Okay, so if we're going to talk monitoring the network, we've got to talk about the protocols.
Definitely.
But there's a lot.
There are, and they matter to the hair on the knuckles network engineer. But I think that if we're talking about just getting into it, dipping your toe in the network water, there's one protocol that matters.
And
Yes.
Yeah.
That would be?
SNMP.
Thank you.
But some server guys already know SNMP.
I think that if you're more of a Linux sysadmin, you're more familiar with it. But I believe that especially in the last several years, SNMP has really not been as important for a lot of environments. So it's
Plus
worth
a lot of people think that it was going away, right? Like overnight, and it's not, obviously.
No.
Yeah, although you can buy things every year with computers and technology that this is going to revolutionize anything. It doesn't immediately supplant all the stuff you've had for 10, 20 years.
And
the
if
way
you're
you've done
Windows
architecture.
based, it's going to be WMI, right? Like that's like your like sweet spot, right?
Yeah, I mean, there's goods and bads with WMI, but yeah, generally you can get almost anything you need out of that.
Right.
So see, I like the universal language of SNMP because like even if you're using net SNMP, the simple basics behind it are the same. So I'd like to quickly go over that if you want to trade me spots here. All right. So when we're talking about SNMP, we also talk about the management bases, right? Your MIBs that you have and your OIDs. OIDs, as some people call them as well.
Yep.
It's ACL or ACL, right? So mainly what we want to show this is in the SNMP world, it looks really crazy, right? Because you have all these numbers that are strung together, but they each mean something, right? So we like to take it on a directional path. So if we look at here, each number that you see is a turn to get to your house. So like I always say, like a MAC address is your social security number, right? Like you shouldn't be able to change those. It's hard, but you still could, right? So that's how I think of those. When you do the OIDs themselves, it's a turn. So as you see here, it's like 1, right? I make a right turn. And then 3, okay, I go down 3 spots and then I make a turn. Like these are just the way the logical flow goes to where you finally get to your house.
So that 1.3.4.1 is really make a turn at the first street, at the third street, at the first street again after that. Like
Exactly.
okay.
Yeah, and it's just giving you directions to get to a place that has information, right? Or the place of which you call home. It's comfortable, it knows where it's at, and it knows what it does. So when we look at that, you still see the same number that goes out here, but this specific OID gives you specific information. So for a server and for network people, because it's universal, it gives us specific information that we can get. So if we're using a universal device poller, we're using health monitoring, we're using application statistics, things like that we want to grab from, we can get it from here. And as you see, this is a vendor, this is the Windows, what we're testing it against. We're able to see it's a display string, so we know what's expected on the backside of it.
Okay, so this is returning a string, but this can also return integers, large integers, percentages, I'm assuming, real numbers.
A table worth of information.
Right.
So it's essentially a relational database that's part of a management infrastructure, and the OID literally is the address. It's like, hey,
definitely,
give me information at this location.
Right, and the other thing for sysadmins to understand is that the MIB is the directions on how to get a piece of information, but when you ask that number, when you do a get against the server and say, hey, 1.3.6.1. whatever, the machine is going to respond back with their specific piece of information. My operating system version is X. My interface number 2 bandwidth utilization right now is Y. That's what you're doing, is you're doing that request using a number, but getting a very detailed set of information back.
Okay. And something really important to know, though, is that you only need the OID, which you can get online, or you can go to the vendor specifically and ask them if there's a piece of information that you're wanting to know exists, right? And so all you need is that OID, and you'd be able to use that within your universal device pool, or you'd be able to use that within server application monitor, the SNMP monitor also. So that's something to think about. If you're not getting specifically what you're looking for, you can always ask out and reach out to your vendor or your support and be able to ask them, hey, what do I need here? And they will be able to give you that OID, vendor specifically, to give you the information that you need.
Yeah, it's a good point, because we get questions at user groups and at conventions and on Thwack a lot, like, hey, I need this very specific number. Can you add it to the tool?
The MIB database,
we don't need to add it to the tool.
It's not necessary.
You know the number, just ask the number, the machine will give you the information back, right?
Right, and now where else can we use these SNMPs at, do you think?
Well, I don't know. I'm playing the systems guy today.
So traps, right? So that's an event type, and that's also things to think about on your security side as well. So traps are able to pull this information that comes back in there. We're able to collect it and manipulate the template.
Okay, so, but if we want to look at it from the two sides, the one is a get, I'm making a request, and a trap is basically the reverse of that. It's the endpoint device, whatever I'm monitoring, sending a group of information back to my monitoring solution, which then tears apart the content.
And actually, the official word for a trap is an inform. So it's the machine saying, I need to inform you that something happened. So it's an out of band, I need to let you know. Now, they're of course not guaranteed, because if the machine is hit by a meteorite falling out of the sky, it's probably not going to send a trap before that happens. But it is, for other non-critical things like that, you are getting it when it happens. You don't have to ask, every 5 minutes, are you okay?
Right.
Are you still okay? Are you still okay?
So I wanted to show you guys, when we collect these, what it actually looks like. So if you see this enterprises, that's taking off the beginning part of the chain, right? Because it's just telling you what folder it's in, right, within the tree.
Okay.
Yep.
And then it continues on to say, okay, and after that enterprises folder, I'm 20580.69.0. So I'm making my turns, right? And I'm landing home to show like what this actually is. So then the trap details will then tell me like what the sys uptime, because that's what this one is going across, what the what MIB type it is, what the OID is standardized on, and what a machine type and everything else of which that it is there. Now, what that gathers you is a plethora of information that you can have within your messaging. You can use this for informational purposes. You can also use these to send them to ticketing machines, because they're based upon values you pull, right? So that's like the great part. I can create a template to send to a ticket machine with the values that it's expecting.
See, now we used to have these in the system side when you had a hard drive blowout in an array. When it was still on a server, when that MIB said, hey, look, they would send an SNMP trap to the monitoring system would say, oh, hey, it matches this particular string and it matches this. Go ahead and send this right to the ticketing system so that we can get an RMA for that drive.
So I need to ask, because they often get conflated together. So those are traps. So what are syslogs? Are those just other traps?
Those are like events. So those are like severity levels of what is happening.
Okay.
Like, so it's not just informational, it's like critical warnings. You can have like BGP neighbors, like the things that are flapping, things that you can actually be concerned with from a network side, but that also helps you from a server standpoint. If you're not having connection, or you're having a connection issue and things aren't switching back over, like you can come to the message center like I'm showing here on the syslog, and you're able to see, is there actual events that are happening almost in real time, by the way. So that's something from a network standpoint that I like for like real-time change notifications and things like that. I appreciate a good syslog to let me know things that are happening, and not setting up the SNMP that comes through there. I find, and this is just my own personal preference here, that it's a lot quicker, it's more accurate, and I'm able to get the information as soon as it's being done. So if you're logging in and you console and you make a change, I automatically am getting that and knowing that the console is happening, and I'm downloading the config and on there.
Okay, so this is similar to a plain text log. If we take just a step back, if we're talking to the sysadmins out there, if you've got an application, IIS or any Apache, some type of web thing, it basically makes a line-by-line log. That's essentially what we're looking at here. It's like any event that matters to this device that you've told it, I want to watch for these things. I want to send things that match this for whatever reason, a cold start, a hot start, a reset, interface up, down. Take that information and send that over to my NMS.
But again, for the sysadmin frame of mind, I think a lot of sysadmins, especially in smaller organizations, are used to going to each machine and checking those logs, whereas syslog and trap were automatically made to be aggregated in a central location. You don't go onto a machine and check the syslog per se. You set them up to go out and go to a central collector, which we're looking at here. The message center is one example of that, and see all of them in sequence. So you're seeing syslog messages coming in from multiple machines. So you see if there's an issue that's affecting a broad range of devices, whether it's all of your access points or your switches or what have you, you can see a problem. Yes, a specific device is affected, but also you've got an issue that's actually affecting a whole area of the network.
I could see this being very beneficial if you, for some reason, have a poisoned route.
Yeah, definitely.
Because all of a sudden everything is saying, hey, new route, new route, new route, new route, new route, all the way through your infrastructure, and someone all of a sudden says, hey, I can't get to blah. And you're like, okay, and then you look and you're like, well, why did all this routing change? And if it's one that's set to propagate, then you go onto the source device, remove that. You can't Control Z, but remove it anyway.
Now, to that point, though, is centralized monitoring and logging, actually, like centralized logging. So I'm like, when you were saying we send it directly to the ticketing system and things like that, I like a centralized logging for a couple of reasons, obviously. Security to always go back on and see what has happened. And then also because from that centralized monitoring, we can then send out to third party or things that need to be designated.
Right.
Yeah.
But you're able to have a centralized location where you can aggregate the data, be able to see it visually for security purposes and back history of what's going on and intertwine that with your monitoring system. Now, when we're talking about how important that can be, the real-time change notification with those syslogs, that is vital for me. So, and just when you're seeing this, we're able to go through here and see directly when the last changes were made. As a sysadmin, this is vital to you because if you are looking at this in your monitoring solution and something just happened with your application and you're getting calls because something's not getting connected, something really wrong is there, you have access to this location. You can go here and look at the top 5 configs because you're knowing immediately what's going on because they're letting you know. If you're noticing there's a config change, which you would see in this section, that's happening right around before and right at the time that people are telling you, you can look at that view change report or create the ticket with the network guy and say, hey, noticed it changed. Is this because I'm having issues with my application? And you can say, that's my server address, and I'm seeing that, no longer it's being permitted, or I'm seeing a deny here, and I'm just think that maybe that's why my users aren't having a problem right now.
I think having this information is critical. We joke about the Control Z and the undo, but that's basically what we're giving you here. This is real time. So when a syslog or trap comes in, there's a mechanism that says, hey, we recognize that this may have made a change. It doesn't necessarily mean it has made a change. If I go into config mode and then I dump out of config mode and I don't actually change anything, maybe I just change a label to itself again, it still gets recognized and the syslog gets sent, or the trap if you have it set up that way. And then I go out and I grab that config and I compare it. Now if there's nothing, now there's a setting in the system that says, if there's no change, just throw it away because it doesn't matter. And for most people, that's probably the case. For me, I like at least keeping that record to say, a change was started, or at least someone went into config mode.
Right. Someone thought about making a change. But I'm going to channel Tom for just a minute, who is pretty famous now for saying that as a system administrator, as a accidental network administrator, you are paid for performance, right? The network has to work, but you're going to keep your job on backup and restore.
Yes.
So that's also the point. It's not just knowing that something changed. It's having the previous version, knowing, as you're looking at on the screen here, these are the elements that changed, and being able to put that old version back. Or if a device critically fails, restoring a network device is non-trivial. It's as or more non-trivial than restoring one Exchange server out of a cluster if you don't have a snapshot. Imagine installing all the software from scratch with all the configurations and everything that you need. That's not an easy thing. Restoring a router where you don't have the configuration backed up is equally difficult. You can't do it from memory.
I will throw you one worse, a very, very large switch.
Yeah.
You're talking a switch with like, I don't know, 8 blades, 48 ports each. Every port could, in theory, have a different snippet for its config. That's a lot of tracking down.
Yeah. So what we're looking at here is the ability to back up the configuration, the ability to know when it changed using those informs, those traps, and then the ability, if you say, oh yeah, no, that was totally wrong, to put the old one back. I think as an accidental network administrator, that is your job number one. Now, this tool, NCM, does a bunch of other things, but right now, today, this week, that's the job you want to know how to do. So with that, I think what we're getting to is the idea that the tools can help bridge the gap between things, right? We mentioned it earlier. And I think what I'd like to do is show a couple of just a grab bag of ways that if you have the right insight, the visualization of it, even if you're not 100% clear of the technology, it will help you. So let me jump in there. Okay, great. The first thing I want to talk about is something that actually system administrators are pretty familiar with, which is DHCP Management. Now we have a tool, IP Address Manager, and there's a whole lot there. We've talked a lot about it in the past on labs and things, but the piece I want to show you here is that oftentimes the system administrators are in charge of the DHCP that's running off of the Windows machines. Yeah. But then there's a whole other swath of DHCP happening, right?
There certainly can be, depending on the infrastructure, of course.
Right, because your routers can do DHCP. Yep. And that's an area that is often left out of the system administrator's purview. But if
it may not be in their Excel sheet.
It may not be there. Please don't use that. Yeah. So, but the point is that with the right tool, you can manage both. And what we're looking at on the screen here is that I've got a Cisco router. It is providing IP addresses off of a particular subnet to my wireless clients, and I can manage and view all of that right from here. So again, isn't going to necessarily change your life, but the idea is if you have the right tools, you can actually manage both your network and your system side together. Now, another example of that is, I've got a WAN router.
Okay.
Fantastic, WAN router, great. We were joking before about how when you get into it, all of a sudden you have all these layers and commands and modes and things like that, and I want to see how interfaces are configured. So what am I going to do for that? Well, if I go to, on the side, if I go to the interfaces screen, and I'm looking at all these interfaces, and I'm saying, okay, this one, there's something going on. It's 44% in or out. I don't understand what it is. Instead of having to jump on the box and SSH and get into it, I actually, in the monitoring tool itself, I can go down and there's the actual interface config snippet. Now, that won't help me change it necessarily, although the NCM tool you were showing would allow you to do that with change control and all those things. But here, within the same screen, or within the same tool set, I can see exactly how it's configured, what's going on with it. I can see the QoS settings or the MPLS settings or whatever it is.
Can I just pause for a moment? Because this is vital. Even if you're accidentally into the role of a network engineer, or you're a veteran and you're in the actual engineering with networking, because before you were multi-threading your workflows, right? Like you were multi-threading your people. There was 4 people, especially if you had port channels bundling that was going on. You're going to each device and getting the show interfaces for each one of those. Add up that time. Okay. Now you can go in there and directly see and know immediately, especially as a network person, you would know immediately if there's something that's missing. Now, from a sysadmin point of view, you can immediately start to understand what has to be there laying out as a template. So this helps you learn. So if you know anybody that's even in education right now, doing vocational schools, looking at certifications, this helps you even on our Orion demo online to get familiar with what a template looks like, so it helps you bridge that gap of understanding as a sysadmin, if you're in virtualization, or if you're even as a network.
So you mentioned port channels, and I think that that's something, again, not a new concept for a lot of sysadmins.
No, it shouldn't be, because if you've ever had a server with 2 NICs in it, most of the time you have them in a failover mode or an LACP bundle. You don't use a PHCP bundle, that's a network only thing. But you bundle them up to either have failover or to double the bandwidth.
Redundancy.
Yes.
Right. However, in networking, you take that and you just kick it up 3, 4, 5 levels.
I like to turn it to 11.
Yeah, and
twice.
So that can be a little bit difficult to wrap your head around. Now, I don't think that a lot of accidental network engineers are going to suddenly trip into the data center with a Nexus machine. But it's a great way of showing that the right tools will give you visibility and make you smarter than honestly you have any right to be when it comes to an area of IT that you don't have depth expertise.
And it goes back to the physical versus logical, right?
Yeah.
So like logically, we're going to show you what it looks like logically, but physically that gets a little bit different.
Well, yeah, because when you think about it, this is almost like, and it's maybe not the best analogy, but it's like a cable. You have a single wire, and then you add another wire and you bring them together, and then you add another wire and you bring those together, and you add another wire and you bring those together.
Shielded twisted pairs.
Yeah.
Yes.
All right, so let me frame up what you're looking at on the screen for a little bit. This is off of a Nexus machine. Again, a really sophisticated piece of networking equipment that will allow you to take a set of circuits that are bonded together from two different machines and then treat them logically like they're all one together. And in this case, one side is operating, the other side is not operating, and everything's working. Packets are passing, but ultimately, you're real close to the fact that, real close to the moment when if you failed, it would be a big failure where you thought you had the redundancy. Looking at PO30, again, the left side here is okay. It's actually a bonded pair of 3 circuits, a bonded set of 3 circuits. The other side of it, PO30, is not okay. 2 of the 3 are down, 1 isn't configured, and this one is carrying the entire load for that side, okay? Now, to do this, it would require a whole bunch of commands for me to, SSH to both of these boxes, get myself down into there and troubleshoot it. But what we're
doing, not even both boxes, right? Like you have to go into each one of the interfaces.
Interfaces underneath that. So you're talking, if we just did one of the sides, you to the switch, to the port to the virtual port channel, to the actual port channel, and then to the members. So we're talking 6, 7 different command lists just to get this information you can get from
one side, which usually you'd have to then relay that information and try to create a Visio
lather, rinse, repeat.
Of which that we all know that our Visio diagrams are always up to date.
Absolutely.
Absolutely, 100%.
They're out of date the minute you walk out of the room.
Right.
After you hit save.
Right. So the point is, this may not give you the commands to fix the situation, but with a couple of clicks, you can see what's going on. You can understand your environment. And so the tools are helping you get that leg up with an area that you don't have the depth expertise.
So this gives you visibility where previously it was obfuscated by, honestly, the complexity of modern networking.
And if you're just coming into it and you're trying to learn technologies, it's nice to be able to visualize what we know that you're command lining on the backside. Some people are visual learners, so it's an easy way to depict that picture visually for them to understand why and what they're doing.
Right. So there's one more, you mentioned the visibility, and I say that if you have to fix something, if people are looking to you and you're in charge, you need 3 things. You need responsibility, which we get as soon as you walk within 5 feet of a device. You need accountability, which again you get along with your badge and the directions to the bathroom in the company. And then you need authority, which is really the challenge, right? And we have to fight for that. The trouble is that when we're talking about a device you don't own, you don't have authority. And what I'm talking about is when you have software as a service, you have devices or you have services that are over the internet. I don't have authority to fix my ISP's devices. No. As an accidental network engineer, I also have to just even figure out what's going on. So I'm now doubly behind the 8 ball. However, if you don't have authority, the one thing that will help is visibility, which is what you said. So what there is this feature called NetPath, which we've talked about a lot.
Yes.
I just want to mention in the context of the accidental network administrator that you have a visibility away, past my DMARC onto these devices that I don't own. So I can tell that this device right here, which is owned by actually Microsoft, is injecting 6 milliseconds of delay through that interface. I can see that very clearly. I can actually, even if I wanted to, I can go call them and say, hey, there's this problem. Okay, that's a whole other conversation about calling Microsoft and telling them
But
about
even
the router.
to dumb this back down, though, to help all angles of this, though, the major fact that NetPath offers is it knocks down that firewall block that we've always used to have. Right? So that's the really cool thing about it is like you are no longer reliant on just knowing what's inside. We take you to that next level and to your endpoint through that TCP port, and we're showing you all the access and which ways of which that it can go based upon the routing table. So if you're learning your inside network, this is a very quick way to map out how your applications are using it, and then it can also show you how you're working with your ISPs.
Yeah, and it's not even strictly for SaaS solutions. What about getting to a data center that's on the other coast where you're going over complete private cloud or a private network, that's MPLS circuits. You pay for them through a provider. Well, if they change something in the middle of the day that causes a latency of 100 milliseconds that yesterday was 1 millisecond or sub 1 millisecond, you need to know about that, and you need to let the people you are actually signing the checks for know so they can make a change.
Right, and that's what we're looking at here, is that at this time on the clock, this is what the network looked like. This is the paths that I was taking to get there. If I just jump ahead a little bit, all of a sudden it changed. So when I have folks, again, the point is that if there's a problem on the network side, the ability to visualize it gives me a leg up.
Okay, so NetPath gives us visibility into networks that we don't properly own. But we've also added some features recently that actually give us a little insight into stuff we do own and manage. So if we could just, okay, thank you.
After you.
So anytime you've gone onto the new version of Core, which ships with NPM 12.3 or the new NCM, what you'll actually get on your left navigation now is mapping.
Mapping.
So a lot of people out there are already going to be familiar with the Network Atlas maps. And we've had them, and I've used them. I've used them for years, and they work really well for specific situations. But, I mean, we've already said the minute you finish making a map and hit save, it's old.
Right.
It's already
out of date. So the important thing to really get out of this is map what you need, not necessarily what you don't need. It's all about kind of reducing the clutter, making sure you see exactly where your problems are so you can then address them. For me, that's really where this starts. So here we have a network map. Now this is a representation of a physical layers. Now it's not purely physical, because if we would take a look here, we've got our core switch here, and we got a physical server over here. But if you notice, it's actually a port channel. So I'm going to drag this out a little bit just so everyone can see. So it's a port channel connected to the SQL server. So although it's not really the physical layer, we're not showing you the individual cables going across. We are showing you that this is the connection between these two devices. What's nice about that is we got the little kind of preview pane where we can actually see, oh, hey, we've got 843 megs per second, and we got 42% utilization. But over here, you notice we're not actually showing you traffic and utilization. We're showing you errors and discards, because that's what needs to be surfaced here.
Right.
Now, one thing I want to say is that you don't actually need to do a full network discovery to get this information. You have to basically check the box that says, show me its neighbors, and if it's a switch, show me its layer 2 or its layer 3 information, and we just start building this. We jokingly call this a one-hop map, because the focus of this map is this core switch. Everything else beyond that is nice, but it's not really necessary. If you want to see the other stuff, you go to that and then make that the focus of the map.
And I'm glad that you laid that out, because when we were seeing this and we were at some of the conferences and stuff, you know, people were like, but there's more connected. And I'm like, understand, but we have to start somewhere into focus, right? Because we're all like hamster wheels, right? So it's just kind of like, let's focus on the task at hand.
Yeah, this is dipping your toe in the pool instead of jumping in with a cannonball.
Right. This goes back to that dichotomy between the logical layer and the physical layer, but also anytime anyone's gone through the effort of building a map of everything, they immediately hate it.
Right.
The everything map it's practically useless. I mean, aside from the fact that any one thing changes on an everything map and it all has to be redone, but then you also have the flip side of that. So I've got my everything map that shows me all of blank. Okay, well now I've got just this one small section. Right. Well, that's great, but I've got 45 of those. So for us, it was really about, you know, let's cut through the noise, let's get down to what actually matters for you doing troubleshooting. And for that, that's errors and discards, how much percent utilization you're using, whether you're getting thrown away packets. These are just kind of the basics you need as a systems engineer trying to understand the network infrastructure. So here, for me, this is pretty simple. I've got to contact someone who knows a little bit more than me as an intro network guy about why I'm getting 14,000, you know, inbound discards.
Right, and then the great thing is that from there you can go right into those interface details and show that interface snippets too, so it helps you to understand what's going on. So I mean, I know we've covered that, but I mean, like, that's just a great way also. Like, you're pinpointing where the connections are, where the actual ports are, and we can drill into it so we can see the snippet. So there's a logical flow that you'll actually get to, because as a network engineer that knows, we know that if there's a problem, we're going to go to the device, we're going to start looking at configs and seeing things.
Well, that's where mapping lives up to its name. I mean, we use maps as a picture of where everything is put, but a map is also the thing that tells you how to get there. So here it tells you how to get to the source of the problem.
and tells you where to spend your time. Realistically, I could, if I was having a problem going from a different data center to this SQL server, where do I start? If I'm the systems guy, I'm looking right at the server. I say, there's no problems there, but it'd be really nice to know that there's some type of problem at the WAN link. Okay, so we've kind of talked back and forth about the physical layers versus the virtual layers, and that's never more apparent for a systems guy than virtualization. I mean, you take one physical server, you chop it up into a bunch of smaller bits of resources, you build little machines in all of them, and ta-da, everything's great. Now, similar to the way we do stuff with Nexus, where we take two devices and put them together and kind of share the work, you do the same thing with hypervisors. You take two of them, you put them in a cluster, you let them share resources, and the virtual machines can move back and forth. Knowing where those virtual machines are is kind of important to troubleshooting. I mean, I don't want, yeah. So the last thing I want to do is spend 3 hours troubleshooting cluster member node A when my virtual machine was on node B.
Right.
That's time I'm never going to get back, and information that, although probably interesting, is not going to help me do my job. So one of the things we've also done with the mapping is to understand kind of the layout of your virtual infrastructure, because you've got your Los Angeles. This is Active Directory Domain Services, which is on an ESX box, which is in the Los Angeles location, which all happens to be monitored by the vCenter. Now, why is this important? Well, because each layer of this, including the ESX host, you'll actually get the network information on the right-hand side that shows all of the devices that are on here. You can also show virtual machines, hosts, nodes, clusters, all kinds of information, including, for me, what it's paired with. So the other relationships it has, whether or not it's another cluster member. But again, we've been talking a lot about the physical versus the logical. The pièce de résistance, as far as I am concerned, is actually application mapping.
Yes, and actually from a network mindset, I love this feature, because then it helps me to see what your mindset is and how things are flowing.
Yeah, because logical maps are really what kind of define the application. The network's the foundation. I don't think anyone here is going to deny that. It's that's the foundation. That's the road. I
appreciate that.
That's the road on which everything operates. It's your personal information superhighway. It's how you get from point A to point B. The problem is not all applications talk the same way. We talked earlier about protocols. How many protocols are there for applications? Like dozens, hundreds, tens of thousands. So knowing actually what's talking to what, why, and where the problems are breaking down, that's important. Like, as an example, we've got a mailbox server, an Exchange mailbox server in the East Coast. We've got one on the West Coast. We've got 88 milliseconds of latency between the two. Well, I mean, that's coast to coast. That's not impossibly bad. It could be a little better.
But it depends on what it's going through. Like
exactly.
I need to know.
If this is personal dark fiber, this is a problem.
Right.
Right.
This is a problem. If you also own personal dark fiber from the East Coast to the West Coast, call me. The thing is, this may not be a problem. However, this is a problem here, because we've actually looked at historical for this, and we know that, oh, hey, this is well outside the norm. What's nice about that is we also know that this mailbox server, which is the focus of this particular map, is connected to this mailbox server, which is connected to this mailbox server, which is connected to this Active Directory server, which happens to be a child of this hypervisor managed by this hypervisor cluster. And you can see every time we click through, we're giving you information at that level. It's all really about scoping. But being able to actually see the logical connections between servers, all the way down to which services, the Exchange replication is the one that's running 88 milliseconds. Well, that could just be someone made a big change to the mailbox. But actually being able to see the individual processes and the CPU, physical, virtual, read and write IOPS of each of them, what port they're operating on, back and forth. This kind of makes the makes the systems engineer really have the insight they need to really do their troubleshooting. Now, why is this important for the network? Well, if these are all red, I would probably say, or at least think to myself, this might be a networking issue. Maybe I need to look at that. However, this is kind of back and forth. That tells me it's probably the server or the application.
Now, something else to think about, though, is that with the different protocols and things of which that can happen there, you can also have QoS implemented.
Yep.
You can have ACLs that are implemented.
Right.
So it's something to think of if you're accidentally a network engineer, if you are having specific issues and you look at that config change area and you can see that something's happened and you know that that's the port that you're using, if you know that's the protocol that you have, or if you know that that's just your devices that are having an issue that they're on when you look at them and you can see the ports that they're on, it's an easy way to see how that flows, because there's always a system engineer and there's always a network engineer way of looking at things that they may not correspond, but they actually visualize.
Yeah, but there is also crossover between those two disciplines. It's a lot of times it's just the way that we're going through and doing our troubleshooting. For me, the power of something like this is actually just being able to understand the relationships between the network layers, the application layers, and what's on the remote sides. Okay, so I think if we go any further, we're gonna have to start handing out CCNAs to the people attending.
I mean, that's not necessarily a bad thing.
No, but like we said at the top of the session, it's not their primary job.
Okay, at least not right now, but hopefully we've been able to break down things so that monitoring the big bad network isn't such a big bad deal.
Yeah, well, I mean, if you find yourself stuck on a network issue, don't lose too much time trying to figure it out for yourself. Jump on Thwack, ask a question. Odds are that one of us or one of the over 150,000 other users will jump on for a chance to help you out.
Right. We should probably let them get back to their day job.
Or the next Thwack Camp session.
All right, that's true. For Thwack Camp 2018, I'm Liana Dotto.
I'm Destiny Bertucci.
And I'm Kevin Sparenberg. Thanks for joining us.